Yes, so today's topic is navy base. So this is one more. Still, we are in classification. Okay, what we have done till now. Let me just brief you up. So see, till now in ML we have just done two major topics. Okay, in ML one is regression, another is classification. Okay, there is one more topic which we will do called clustering. Okay, this is classification. This is clustering. So these three topics we have covered. There are a few more topics, but these are the big ones. Okay, whatever we have covered is the bigger ones. Okay, and we will now use different data sets. Okay, maybe I will get 10 data sets. Okay, and I will give you individual data sets. You have to apply it either in clustering or classification or regression, and you have to submit your assignment. Okay, report, final project. Okay, so now a new algorithm inside classification. Okay, so inside classification there is a concept of navy Bayes classifier. Okay, it works on the Bayes theorem formula. Okay, what is that? P probability of A by B is equal to probability of B by A into probability of A by probability of B. So what is A slash B, B slash A, and P of A and P of B? Let us see. Here, this is an typical case where there is a machine. Okay, that machine can be prepared. It will prepare wrenches. Okay, 30 wrenches in 1 hour. Okay, some tool in 1 hour. Okay, 20 tools in 1 hour. There are two machines, one machine, machine 2. One machine is slightly slower, it will prepare 20 machines per hour. Another machine is slightly faster, which will do 30 machines per hour. So what is the probability of wrench coming from machine 1? This one. What is the probability of the wrench coming from machine 2? 20 divided by total. Simple probability. Okay. This is P of machine 1, P of machine 2. Similar to P of machine 1, P of machine 2. Okay. Like this. Next. Out of all this product produced part, we see that 1% are defective. See, 1% means what? 1 divided by, so 100. So 1% will be defective. Okay. And then out of all the defective parts, we can see that 50% come from machine 1 and 50% come from machine 2. Although machine 2 will produce less amount of items, it is producing equal amount of bad. So machine 2 is actually bad for us. Okay. So P of machine 1 defective 50%, P of machine 2 defective 50%. So what is the probability that a part produced by machine 2 is defective? So these two are different. Okay, out of the total defective parts, 50% of the defective comes from machine 1, 50% of the defective comes from machine 2. Now, what is the probability that a part produced by machine 2 is defective? Okay, machine 2 will produce 100 parts, and what is that probability that it will produce a defective part? Okay, that we will try to understand using Navy Bayes classifier. Okay, why it will come under classifier? Effective, defective or not defective, that's why it is a classifier. Okay, classification can be done only on yes or no, true or false, defective or not defective, working or not working, that kind of thing. Okay, now here these are the two categories. Okay, defective, not defective. Okay, a new data point comes here. We want to know whether this person actually it is not defective, not defective. It can be also used in walking or driving. Okay, so there are certain people who walk to their office, certain people who drive to their office, and here is the salary versus the age. Okay, so people who are younger, they prefer to walk. People who are older, they and with high salary, they prefer to drive. Okay, so for them money is not important. For young people money is important, so they will uh, prefer to walk. Now there is a new person. We want to know whether this new person will walk to office or drive to office. Okay, he is almost in between. We are not sure how it will work. So here is the formula. the probability of person walking to office, probability of x walking to office is this one. Okay, then what is this? This is called as likelihood. We will see what is this. This is called as prior probability. We will also see what is this. This is called marginal likelihood. Okay, we will see this all these things with a good example. Okay, probability of a person x driving to office or driving to office. Okay, so p of x of drives, this is called likelihood, probability and marginal likelihood. So this will give the probability that x will walk to office. This will give you the probability of x driving to office. Whichever probability is higher, our algorithm will tell that person is going to drive to office or walk to office. Okay, now let us see this algorithm. See what, in order for this algorithm to work, what are the three things it needs? It needs four things. Okay, basically four things. So it needs the following things. Okay, first one by one we will see. Okay, walks, person walks to office. So p walks. So we got this p walks here. Okay, next one, p of x. Okay, likelihood. Let us see what is that and how it works. Okay, last one is we have to just apply it. Okay, now let us see what are the three things. So first we need this one, followed by this one, followed by this one. Okay, okay, so we need all these three four things. So one by one let us see. So p of walks, number of walkers divided by total observants. So how many walkers are there? How many dots? Okay, total dots, total people. Okay, so total data, out of which how many will walk, that will give you p of walks. So we got this. Okay, we got this one. Next, likelihood px slash box. So what is that? Px slash box is this one. Okay, black one. Okay, this one. What is that? Number of similar observe. Before that, let us see this one. Okay, before going to px slash box, let us see p box. So p box will be your purple, right? Purple, I'll take this one, purple. Okay, here number of similar observation by total observation. Okay, here the our point is at this point. Okay, it is here somewhere. Okay, our x is here. We will take a small radius around this x and we will take our total observation. Okay, 4, how many points are there around this x? That is 4. 4 divided by 30. Okay, then what I will do, I will come here and in the same radius I will remove the people who are driving. Only people who are walking I will keep. So this guy will go, this one who was there walking, driving will go. So we will be left with only 3 of them. Okay, here only 3 of them will be left. So 3 divided by total number of walkers only. Okay, this is total observation, total number of walkers. So 3 divided by 10. Next we have to just apply it here and we will get the result. So what is the result we will get? We will get 3 by 10, 0.75. So the probability that the person X is going to walk is 75%. Okay, and the probability of him driving is 0.25. So similar to the way we have done this calculation for all these three cases, we have to do the same for the person driving. Then you should get exactly 0.25. Okay, that's how you should get it. Now this is navy base classifier. If you have any doubt, I can explain this again, or else I'll jump into the program and I will show you how this program will work. If you want me to repeat, just ping a message, I will repeat, or else I will go to a program and I'll explain. Okay, so now navy base, let us see the program. Okay, so navy base, again first step is same, second step is also same, scaling is again same, only change is here navy base Gaussian, and we are doing and we are running the algorithm. So whatever is done, right, everything is taken care inside the algorithm. Okay, so here there is no much of brains involved once you know which algorithm to apply. Okay, so then third step, this is also our old normal step, this is predicting, and this is confusion matrix. Okay, visualization part I will comment because it will take too much time to observe it, but you guys have to do it when you guys have time. Okay, because I have limited time here, so I'm not showing the output. Visualization part I'm not showing. Let us see the accuracy score, then I will share the result with you. Okay, yeah, the accuracy score is 0.9. Okay, which is low, but still we are okay with that. Okay, oh, there is a plot which I had not commented. I think it is trying to plot that. Okay, so this is the output which will be used for all the data. Okay, so accuracy score will give you a very good idea how the confusion matrix will look and what is the prediction. Okay, now I will share this code, you guys can try. So not here. Okay, try this code for 4 minutes. You guys can work, try to see the visualization part also if you can, or else then I will go to the new topic. Okay, let us start. I'll start in 1 minute. Okay. So now let's go to the next topic. Next topic is decision tree. Okay. So we have finished kernel SVM, k nearest number, logical regression, decision tree classification. And now I will do decision tree classification, random forest classification. Okay. So decision tree classification. See, already we have done decision tree once in regression. It works exactly similar, but now we are applying it for classification. But model algorithm will be different, but concept is same. Whatever it was there in regression, same thing will be applied. Here, how this works is, it will classify. See, imagine this is S. Green is S, red is no. Okay, but you cannot draw a line easily. Okay, if it was a simple thing, you could have drawn a line. Okay, for example, okay, if there was this line and we had small, imagine these are all S cases. Okay, and these are all no cases. Then it was a very simple thing task of drawing a line to classify between yes and no. But now what has happened is your algorithm has got changed. Okay, it has been divided into this red here and green here. You cannot classify it very easily. So here, this will help us. This algorithm, decision tree, it will divide our data into splits. Okay, what is the first split? X2 less than 60. First split is for this line, X2 less than 60. Okay, this is split 1, there where X2 is less than 60. Second split, X1 is less than 70. Okay, this one is less than 70. This is, sorry, this one, split 2 is this one. Okay, X1 is less than 50. So x1 is less than 50, this case. Next one is this split 3, this one. X1 is less than 70, then x2 is less than 40. Like that it will split, so that you will be able to group your data in a nice way, true and false, yes and no way. Okay, this is how decision tree algorithm will work. Similar to decision tree algorithm, there is random tree forest, which we already know. What is that? That case, imagine there are, these dots are there, right? There are 100 dots here, total 100 dots are there. Instead of taking all 100 dots and classifying it and splitting it, we will take say 15 dots. We will take 15 dots and do classifications. Exactly what we had done here, we will do it on 15 dots. Then randomly we will take another 15 dots, and randomly we will take another 15 dots, and we will take all these 15 dots and we will apply it. Okay, and then how many such classifiers you'll get? Say 10 different classifiers you got. Okay, then what do you do if you want to put a new value? Okay, you have to, that new value will go into all 10 different algorithms, and each 10 different algorithm will tell whether that point belongs to which category, true or false, yes or no category. Okay, and then you will average the final result and you will get. Okay, that's how random forest algorithm will work. So this is decision tree, where you are splitting it into these parts. Random forest, you are doing exactly this but on less number of data multiple times. So 15 data out of 100 data you will take random 15, then again you will take random 15, then you will again take random 15. So coverage is more, and you will start doing more and more classification, and then you will do averaging, so that gives better result, but it will take time. Okay, if you have any doubts I will explain. Take 30 seconds to tell me. If not clear, ping me. Okay, no, just so fine. Now I will go to the code. First we will see decision tree classification. Then we will see random forest classification. Okay, so decision tree classification is here. First step is again same, second step is same, third step is also same. Here we are just taking decision tree classifier, that's it. Then we are passing this classifier here and we are training it. So these are the three things, that is it. Okay, I will now share the code. Before that I'll run it. We'll see what is the accuracy of decision tree classifier. It is giving us an accuracy of 91%. Okay, decision tree classifier. I will share this. Okay, this is decision tree classification. Then random forest classification. I will share that. Oh, it is not showing up. Okay, so random forest classification, everything is same. Here we have to use n estimators. What is this? N estimator is how many times you want to repeat that category. Okay, so instead of taking all 100 points, we were taking only say 15 points. How many times you want to do that on your data? Say 10 times. I will be doing 10 times small splits of data. Okay, I will take small chunk of data, I will do decision tree classifier on that, and I will do averaging. Okay, that is what it will do. Okay, we will see what is the accuracy here. We must see slight improvement versus the normal decision tree. Okay, so this shows almost 91 only. So if the data set was bigger, I think it would have given 92 or 93%. Okay, we will try to increase the number of estimators to 20 and see that a slight improvement was there. Okay, so I will share this code also. Okay, I am sharing this. Okay, you guys can run both of them. Take exactly 10 minutes, then we will go to a new topic. And if you have any doubts, kindly let me know which topic. If you want to repeat any topic, you tell me, because next topic is a new topic, clustering. Okay, we will go into clustering. So if you want to understand more, you can just message me. I want to this particular data, I want to understand, you can tell me. Okay, okay, hopefully you guys are trying. So the reason I'm giving you time is so that you guys can ask if you are not clear with anything. Okay, now let us continue. Okay, so here there is the next topic is called clustering. Okay, what is clustering? See, so till now what we were seeing is yes or no kind of thing, okay, where we were trying to classify between yes versus no, okay, yes versus no. Now we no longer do that, okay, we are doing something else. What we are doing here is in clustering, imagine there are small dots. Okay, now this dot we can visually say that it can be divided into three groups. This is one group, this is another group, and this is our third group, okay, we can say that these are the three groups. But in actual case there can be multiple groups, okay. For example, you guys are in your class, you are 40 students or 50 students. What if you if I take 10 different inputs from you, your hobbies, your interests, your food, what you like, books that you are interested in, and the kind of movies you like, the sightseeing places which you like. If I take all these 10 inputs, and then if I try to make groups, I will see that few of your nature is almost same, okay. Out of 50 students, I can make say three groups, and I can put all of you in individual three groups, okay. One of the three groups I can put, then I can apply some of my algorithm on to those groups which are like minded, okay. So there will be one group which are like interested in studying technical things, and some of the groups are interested to do management work. Some of the groups are interested to do extracurricular activities. They are very good in sports, they are good in marketing, those kind of things. So I will be able to apply it in my own way, okay. So that's how this clustering will work. Okay, now let us see what is this clustering. So now you understood what is clustering, okay. Now if you want, there are basically, it's not like classification, there are multiple types. Here there are only two types of clustering. One is k means, and there is another is called hierarchical clustering, okay. So in k means, what it does is, let us directly jump into the example, okay. Before seeing what is that algorithm do, we will directly jump into the graph, okay. So here there are say 15 points, okay. 15 points are there, or maybe 10 points are there, or maybe 15 points are there, imagine, okay. I will, I want to do clusters of two. I want to make this into two clusters, okay. I want this group into be two parts. So what I will do, I will randomly pick 2 points. I will randomly put, I don't know the data, okay. I will randomly put 2 points in this space, and I will decide what I will do is, I will see the, I will make one of the point as group 1 and another point as group 2, and all the points which are close to this blue one, I will make this as one group, and all the points which are close to red, I will make them as red group, okay. So finally what I will do, next step, I will get all these 4 points. This is my centroid, but actual centroid when I see, I'll understand that this is randomly put. If I keep it here, from this point all the points are equidistant, okay. So if from here these 4 points are very far and these 2 points are very close, but if I move this here, the centroid for all these points will be almost equidistant. So I am going to shift my blue centroid and red centroid, and I am going to finally get this model by doing the trial and error method, okay. So I got two centroids and two circle here. This is how I made two groups. Now why only two group I should make? I could have made it into four groups. Okay, clusters is nothing but it can be 2, 3, 4, 10. It can be any number. Why have made only two? There is no reason. Okay, I could have made it into multiple. Actually, I am not sure how many groups I should make. I have to first decide how many groups I should make. So for that, there is one intuition called as K means intuition. What it does is it will start with say maximum number of clusters, say 3 clusters, okay, or 10 clusters. Then it will follow this method whatever we have done. Instead of 2 points, if I had 10, I had decided k is equal to clusters equal to 10, then I should have had 10 such points, okay, 10 such square points. So instead of 2 red and blue, I should have 10 different points. Then it will do 10 different circles at the end. Okay, here I have considered 3. Okay, so I got 3 clusters. Then what I will do, I will take average of this distance, okay, and I will square it using this formula ti minus ci whole square. Point minus centroid square, and sum of that I will do for this cluster, then I'll do it for this cluster, and then I'll do it for this cluster. I will get three different values, and I will get one final value called WCSS. Then what I will do, I will imagine there are only two clusters, and I will start this again, okay, this phenomenon again, and I will get two clusters. Then again I will do this formula, and I will now have only two circles. So this and this will be present, the third one will not be present because there are only two clusters present. Okay. Finally, what I will do, I will imagine there is only one cluster, and I will put everything in one cluster, and I will get one WCSS value. Okay. For 3, I will get one WCSS value. 2, I will get one WCSS value. 1, I will get WCSS value. If I had 10, then I will have 10 different WCSS value. Higher the WCSS value, it is bad for the, according to the algorithm, lower the WCSS value, better is the result, better is the grouping. So that can be decided using this plot called as elbow method. So this is the WCSS value for one cluster. Okay. See, this is the WCS value for one cluster. So that is this one. This one. Next one is for two clusters. That is this one. Three clusters. This one. Four clusters. Five clusters. Six, seven clusters. Eight clusters. You can see for one cluster it is having very high. So we are rejecting it. Two cluster is also very high. We are rejecting it. Then you can see almost for 3 to 10 there is no much difference. Okay, there is no much difference between 3 to 10. The values are changing, but very small, the variation is quite small. So in that case what we can do is we can take the one with the least, we can take this value as our average value, maybe or 3 or 4, because if you group the 40 students into 4 or 3 groups, that will make more sense instead of dividing the groups into 20. So in that case I will not be able to apply any of my algorithms there. Okay, if I am able to divide people into smaller groups, I can give some, I will be able to apply my algorithms in a more efficient way. Okay, so this stage here is help you to understand how many clusters to decide. So finally what is the output of this clustering is grouping. Okay, 40 students are there, I will divide it into 5 groups. Then what I'm going to do with that group, that is secondary. Okay, I can do anything with that groups. Okay, but I am able to divide the groups in a nice wonderful way. That is how it will work. Finally, this is the algorithm. If you want, I'll explain this again. Let me explain this again. Okay, so that Okay, so here let me explain this again slowly. See, these are the 40 students. Okay, imagine this is 40, there are 40 dots. I will decide if I am going to do two groups from this 40 dots. Okay, either you can visually do one dot, one circle here and another circle here. This is visually you are doing it, that is from your eyes you are doing, but reality we want this to be done from a code. Okay, from a code this has to be done. So what I will do, I will randomly put 2 points. Okay, I am randomly putting this 2 points. So this point is randomly placed and this point is randomly placed. Then what I will do, I will start seeing distance. Okay, this versus this distance. So which is smaller? This is smaller. So I will make this point as blue. I will make this as blue point. Okay, I will make this as blue. Next, I will see this distance with this distance. Okay, again I will make this guy as blue. Then I will do this distance versus this distance. I will see that this is red. Okay, so I will make this as red circle. Like that I will do for all the cases and I will get two clusters. Okay, then the centroid I will reconfigure my centroid because this point is here and most of my points are here. So I'm shifting this point to this point. Okay, so that I can get a nice cluster circle. Okay, like this I will be able to get. So this is how your model is ready. Okay, now how many clusters do you want, that depends on a method called as elbow method. Okay, that elbow method, what it will do, it will take all, say if you want 10 clusters, it will start from 10 clusters. Your 40 students will be divided into 10 clusters. Then we will apply it to a formula to do distance PICI. So what it will do, PC, the distance from this to this and square, distance between this to this square, all these numbers and finally you get a sum. You do that for this one also, and add all the three, you will get one WCSS value. Once you get the WCSS value, say you had 10 clusters, then you move to 9, 8, 7, 6, 5, 4, 3, 2, 1. Finally, you have one big cluster. That one big cluster, you will get very high WCSS value. Next, for second one, you will get slightly lower. Third one, you will get slightly lower. Fourth one, lower. So, we should ideally select clusters between 3, 4 or 5, because if you keep increasing number of clusters, the data will have less value. Okay, because imagine Amazon wants to send a coupon code to certain kind of people. What it will do, it will first do clustering. Okay, then it will divide that. Maybe it has done 5 clusters on its customers. Okay, all the people who have Amazon app, they have divided them into 5 groups, and that one particular group who is more active, who are like young, say for example you students. Okay, you will be interested for a new phone. Okay, you will come to know that there is a new phone which is which is cost effective and very high speed, and camera is very nice. And whereas a senior, maybe your parents, who are not bothered about high speed, nice camera, high resolution mode, 8 GB RAM, they are least bothered on those things, about those things. You guys will be interested to know that, yeah, it has 8 cores. You will be interested. So, why to give that offer to someone is not interested? Instead of that, that particular offer can be given to the students who are really interested on those things, and the price is very less. And you will be very much interested in that. Okay, so those people they will target using these clusters. Okay, they can divide it into that part also. Okay, this is how this will work. Now let us see this algorithm k means. Okay, so here there is slight change in code. Okay, in this data there is nothing called as input and output. There is only input. Okay, we are not getting any output as such. Output is number of groups. Okay, so here what is this data set? Small customers are here. So this is a score. Okay, this is customer number one. He is male, his age is 19, his salary is this. Generally he spends $39. Okay, no, his rating is 39. Means he will spend so much money. This guy will spend so much money, this guy will spend so much percentage of money. Okay, this is the data set. There is nothing like output as such. Okay, now with this, what we will do, we will use D and E, column D and column E, and we'll start making it as groups. We can apply C also. Okay, C D E also we can do, even B C D E. But in B C D E you cannot use directly. You have to convert this B into numbers. Okay, strings cannot be applied into algorithm. Okay, you can apply only numbers. So if you do CDE, we cannot plot the data. Okay, plotting will be possible only with two variables. Okay, if you have three variables, you cannot plot it using algorithms. So I am taking only D and D. So D and D is nothing but 3 and 4. Okay, that is X. Then this part of the code will convert, and it will transform our code into such a way that it will give you the elbows. Okay, we will see the output here first. If I run this, yeah, so this is the output. Okay, this is telling me that if I use 3 and 4, it is giving me a elbow where 5 or 6 if clusters, if I select, I will get good result. Okay, if I use 2, the result will not have much value. If I give 8 and 10, it will give me clusters, but it is not having much significance. Okay, so maybe 6 or 5 is the realistic number. Then what I will do here, I will take this 6. Okay, and I will uncomment this. Then maybe I will use 5. Okay, because this graph is meant for 5. Okay, so this is your data which has been classified in 5 different colors. Okay, red, green, blue, light blue and purple. 5 different clusters has been formed. Okay, I will share this code and data set both. Okay, let me share both of that together. You guys can run it. Okay, I will stop sharing my screen also once again.